Hello and welcome to yet another stream in the life of a bad programming guide. Um, yeah, I figured I might as well just continue working on the project here. Um, yeah, so if you've been following my community updates, you'd see that I actually implemented a complete UV sphere here. At the end of the last episode, I implemented the mesh shader, which had restrictions on how many vertices it could generate due to the restrictions on such a pipeline. Um, I said on the stream that I was gonna what do you call it? Um, leave it at that, but sometimes you decide one thing and then end up doing something else. So I actually wanted to take the mesh shader algorithm and implement it on the CPU side, and then ended up implementing the old debugging pipeline where we draw the spheres as part of the primitive pipeline. I also renamed most of the stuff. Um, yeah, yeah. Um, yeah, so I ended up doing that, and I actually created an algorithm that's almost done. So I created an algorithm that builds the UV sphere indices, or rather vertices. That's basically just the same thing as um, our mesh shader here. Let me just close this so I don't get too distracted. Yeah, so basically I ported this. Uh, Wait a minute, we used it. Anyway, so it takes a center point, a radius, and then a series of latitudes and longitudes in terms of how to um, segment the UV sphere. Yeah, that's basically nothing new. I made it take the parameters as you saw, uh, and it's of course able to generate whatever's needed in terms of vertices, but then I can build sphere indices from the same parameters. Right now it only works if the the longitudes and latitudes are even. Uh, yeah, actually, this should also be uh, like this. Um, but yeah, basically, it kind of like draws what we saw from the mesh shader, the horizontal rings, and then a line that connects all the horizontal rings, since um, yeah, the first point in every ring is like the next point in the series of indices. So when we build a sphere like that, we will end up with all the horizontal rings and then a half ring on the one of the series of vertices going on the vertical in the vertical direction. Yeah, so you need to compute those. I right here complete the ring, so I draw another half circle around the vertices that are in an evenly sized sphere. Actually, it's just completely parallel to the other part of the ring, but it would differ in a odd based thing. And then I have a series of rings to build where I build the whole ring. Uh, yeah, so that's basically it. Let's move this. This is not going to be used. Yeah. So that's basically it. So, yeah. We now have the ability to draw these spheres, upload them to the debug vertex and index buffer, and yeah, and we can of course do instance rendering and draw a lot of them fairly cheaply. Let me see. Okay. Yeah. So debugging is a breeze now. We have ABBs and spheres based around the UV sphere. We can color them, we can do whatever. Yeah, so what's next? Well, I made a poll on the community tab of my channel, and been thinking about implementing, for one, a skybox for this game, and implementing a more robust model importer based on the FBX file format, which is pretty standard. And I've also yeah, considered other stuff, but that's basically the primary considerations I've been having. Yeah, so feel free to check that out and let me know what you would prefer me to do. Yeah, but today is going to be a fairly short stream since I have stuff to do. but I thought we might as well just get some work done in implementing a more dynamic lighting system. So yeah, right now we will support a directional light, which is hard-coded. Actually, the very keen rendering renderer programmer, graphics programmer would have noticed that this shadow is actually totally whack, uh, judging from the shading of the object. So we have our shadow map here, and as you can see, the model itself casts shadows on itself in several places where it doesn't really make sense, since the two sides here are completely shaded. Also, the back side of the model is almost entirely shaded. You can see some lights here and there, but the head is kind of shaded on that side as well. We also cast a somewhat awkward shadow here. Yeah, so basically something's wrong. And um, we will try to, or rather, I know how to fix it, but we will be building a more robust lighting system, also where we can kind of like change the whole lights more dynamically. So right now, when we create a lights, we have a direction and a strength. The strength is actually the color uh, of the light. Um, yeah. The problem with these two components here is that, well, I guess you could say that they are not very well aligned. So we would want, I think it's 8 bytes, and this is 6 bytes. So we would have problems in terms of alignment. So we would do something like float, padding, load, padding, and that's not great. Um, we could use a more generalized structure, but yeah. It's overall not great. Yeah, we would of course add the light information to the pass data. Let's do something like that. So this is also padded correctly. We can might as well just use that slot. We could also just create float force here, and then kind of like just use whatever we need from that. That's probably better. That's probably better. Yeah, but anyway, we would want to implement a uh, application side lights. Let's see, frame data. Let's call it, let's rename it transient. Yeah, we have no problems with that renaming. And let's see, it's frame numbers, previous frame, last debug frame. Do we actually use that right now? Yeah, we do set it, but right now we don't use it for anything, right? Yeah, so we don't need that right now. We update that. We do not even use this one anymore. Let's clean up this stuff here. But we do create the primitive data. Let's rename it. Debug packets. Do we actually use this one? Yeah, I think we compile it into a debug packet. Okay. Draw related buffers. Hello, Bob. How are you doing? Yeah, you seem to be checking in almost daily. Same as me. How are you doing? I'm pretty good. A bit tired. I've been at work all day. Got off maybe 1.5 hours ago. So yeah, just wanted to do some streaming. What are you working on these days? Okay, so we should probably add a, maybe not a rendering type, because it's kind of like shared between the front end and back end of the um, the renderer. Does it include the resource types? No, it doesn't. And when do we want separate ones? I mean, resource types are just generalized collection of data. This would eventually contain rotation, orientation, quaternion. Yeah, probably just the orientation. What's GLM? Oh, it's the math library, right? No, I don't. I use DirectX Math with intrinsics enabled. But I think you could use whatever you want. Why do you ask? Yeah. Also, I think let's see, performance test, DirectX Math, intrinsics. Yeah, so with SEC4, it seems like some people think that DirectX Math is pretty fast. I don't know with AVX. I'm actually doing AVX2, but it doesn't have full AVX2 support, I think. Yeah, so this dude seems to claim that DirectX Math is pretty fast, pretty fast, but I don't know. I actually think that someone didn't he use the extended AVX registers to hit higher utilization of registers compared to cache lines? I don't know. Hello. No, it's not that hard. Cube maps are pretty simple. It's basically like a 3D texture. I also did a cube map implementation for point light shadow maps on the other project. Let me just show you. Let me just compile it. It's been a while apparently. Uh, so if I swap camera here. So this area here is actually based on cube map based shadow mapping, where this point lights, which you can't really see, but you can see some of the specular from the lights right here. There's a light kind of like here. Let me see, can I enable debug? Yeah, the light is here, and as you can see, it casts shadows on all sides, which is yeah, basically cube mapped. No, I'm not meaning that you run into cache issues with cache lines, but a cache line compared to a register is basically the register is free, while the cache line is 2 to 3 cycles slower than if everything is just in register. And since the AVX registers, at least AVX 512, allows you to load a lot of different uh, um, what do you call it, floats into registers at the same time. You could probably get some optimization right there, but I'm unsure. I think some guy on Stack Overflow um, actually did some toying around with AVX 512 and 4x4 matrix multiplications, but I'm not sure. Maybe it was for bigger matrices. I mean, the performance gain is not great. Uh, I mean, 2 to 3 cycles for cache L1 cache compared to a all-in register computation. Well, it's not a lot of cycles, and it's definitely nitpicking. But what do I know? I'm not an optimization expert. No. I was talking about probably a direct assembly implementation using the AVX registers, but yeah, no compiler will be able to do it. But I know it's more theoretical than it's really usable in practice, and it doesn't really matter that much that you're reading from the L1 cache compared to the registers. So yeah, I was merely speaking in theory. So I guess I'm trying to say I agree, but in theory you could probably get a bit more performance out of your CPU, but who cares? Okay, so let's see. I think that these two things will end up colliding. Didn't I have? Yeah, I have the material thing collide uh, with the material properties here. Yeah, just to split out the unique identifier. But that was back when I was still unsure how to do it. I'm still unsure, and I'll probably change it. So maybe the pass data is implemented right here. Yeah, and it will relate to the pass data as well. Does this header here include resource types, which is this? Okay, so we could, when we do our draw stuff here, we could, let's see, resource types as well as rendering types. Yeah, we do both. Yeah, we could do different namespaces as well, but it doesn't really matter. I should just write something and then change it whenever needed. Okay. This will definitely contain a light. Let's see, struct. Light, directional. And in our implementation, which needs to be fixed, pass data. Okay, I'm not done yet. That's why. We have a direction, position. Okay, we might end up in a situation where everything is mapped then, but I'm wondering if the alignment is. Yeah, I'm not sure. I mean, the actual rendering information is different than our front-end implementation, because the front-end implementation would probably contain more information. But I think if I do something like blah and float blah to, even though we end up at 12, which would be the same as 3 float 4 vectors. I'm unsure of the actual alignment. Okay, we can try it out. Although, I'm considering storing a position, a color here, and then a yeah, what else do we use in the shader map? Center, scene center, and just simply store it and pass it around. But it's not really relevant. Oh, whoops. Yeah. I just think I'm gonna do float force here and color direction, and then I'm gonna clean up this. Direction. And let's just inside our computer lights algorithm. I can click it. Compute lights, directional lights, strength, XYZ, XYZ. Should be fine, right? Oh, of course, color. XYZ. Okay. Okay. So that's fine. But yeah, for the renderer backend, we will keep a different one. Color. Last component not used, but created with padding in mind. Direction. A zero vector here. Also, the last component is not used here either. Set to 1 to mimic alpha. Now let's just set it to 0. Doesn't make sense to have an alpha level of a light color. Okay. All right. Let's do a lights directional light. Directional light view projection. Delta time. Okay. Let's see. Is that, yeah, that's the field. Yeah, so this knows about the camera. I guess that's fine. Let's do a struct lights. Let's do something like DirectX, make some float position. And let's do either 3. Color. Let's do a direction vector here. Let's do a float 3 focus position. Now we have the ability to actually let's see, does this actually include the renderer? No, it doesn't. Okay, it's actually on the renderer itself, so maybe we want to move it outside of the renderer. Probably gonna move away from the instancing singleton pattern into a global. And this will allow us to create a um, scene global light. Main lights. Maybe, yeah. Yeah. Where is this defined? This doesn't contain anything that is specific for DirectX, so we could move it into this right here. And let's keep the draw calls and the specific API stuff right there. Yeah, we could do that. So move this to a rendering type. Shouldn't make any difference. And this could be something like in here. That would make more sense than whenever our backend needs information about vertices, scene parameters, blah blah blah. It can get it, but it can also access, for instance, a frame data reference here, and we can remove that. Frame data reference frame data, and we can this doesn't know about the camera. Uh, camera, camera. And let's see. There we go. Let's just do something really simple here. There we go. And inside here, don't I? Oh, it's because of the global stuff. Oh, I hate it. Or rather, in the singleton stuff, I really hate it. Yeah, it should just be a global, not a singleton. But I'll rework that eventually. Okay, I got distracted, sorry. Anyway, does all this compile? No, it doesn't. Debug primitive, blah blah blah. Oh. Is this actually used anywhere? Resource types. Let me just try moving this. Game types. Oh, this uses it. Okay. Well, I guess I can't do that then. Then I'll just cannot open camera. Huh? Oh, I maybe need to, yeah, I need to step out of this directory, of course. Okay. 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 Oh, of course I need to set the camera pointer. Let's see. Okay. Oh yeah. No. Let's try reverting back to. We made several changes, so okay. Okay. Maybe we don't. Huh. What did I mess up? Oh, I know why. It's because let's just redo all of this. It's because our now we have changed our past data. So let's update it. I think we changed our past data to be yeah. So this and then a matrix. And let's do a float 4x4 here. So this is basically it. Let's update the shaders here. Yeah. Whoops. There we go. Whoops. Yeah, so this uploads that. Let's see. Subscript view projection light. Did I not? Okay. Okay, we're still not completely done. Also, everything is just shaded now. Minus size of XM flow times 2. Should probably won't change anything. Let's see. Shadow mapping. Yeah, we also need to update these. Yeah, we should maybe create a common folder somewhere. Yeah, we should. This gets really, really cumbersome. So, common HLSLI for include. Let's see, and we can include like this, right? Common.HLSLI. Okay, let's do. And we of course need to there we go. I mean, the past data and stuff like that is supposed to be updated for all shaders since it will not change. Does it even care? Yeah, it does. Does it even care? Let me see if I can disable the what do you call it? Pixel shader 16. So if we only do a 1 here, will it compile? It will compile and it will work. So we don't need this anymore, right? No, we can delete it. Pixel shader, get out of here. Our shadow mapping will only have a vertex shader. The object data might vary. Okay, we're done, right? Yeah. No more work to the polygon lines. Not that we need it in there, but let's just make it a good practice to include it. Okay, we should be good then. Nope. Redefinition in the ABBs. Okay. Not there. Okay. There we go. Okay. And our frame data would probably contain some light information. Okay. Yeah. Okay. So here we will add, we already have a light. So we can set our directional light here. Directional light. Copy our light information. Um, Main light. And we will pass along the pointer here. I really hate that singleton pattern. God damn it. Oh my god, what I hate it. It's so much typing. Direction we'll grab from our frame data. This should be a float 3. Uh, yeah, we can't convert it. Boring stuff. Yeah, it doesn't work. Let's see, do we have a special constructor? Yeah, it doesn't know that it's basically the same. Okay. We will do this like this. No, no. Color. Okay, we assign our camera. We upload everything except the hard-coded view thingy. Okay, this means that we upload our what do you call it? Let's see. Let's order this camera. camera data. This should also take a float delta time. Let's see, we call it delta time. Frame data should have a float delta time. Okay. Okay, so we arrange our stuff. And let's do some light. Upload to buffer. Main light. Let's just mirror whatever we have already. But maybe just a different color. Only a red light. That's what we're gonna do for now. And we will make our shaders use it. Right now, let's just see if everything on the CPU side here will compile and run. Everything runs fine. Okay, so inside our polygon pipeline here, in the pixel shader, we should comment out this. And let's see our past data. Past data. Light directional is what we take, right? Yeah, directional light. And we, yeah. Okay, so this should work, right? Yeah, we're now using our lights. Okay. um, okay, let's create a function that I deleted during one of the earlier streams. Let's create a static void temp render UI, render a UI. So we will implement a temporary ImGUI based UI that our application will actually run. So that we can play around with our different controls. ImGUI begin, ImGUI end, renderer controls, and let's do a ImGUI slider float free main light color. Can I actually use the main light? Oh, main light dot color. Does it allow me to? No. Yeah, XM float can't be. Can it be cast as an array? Union. I mean, this is a union. Yeah, I guess you can't make a union out of a type like that. I'm not sure, but I suspect that you can't. Anyway, um, let's see. Float color. Color. Oh, wait a minute. I need to do like this. If we activate it, we set. No, we can't do that. Okay, let's try that. And we can adjust our lights here. Let's initialize this as We now have control over our lights. That's pretty great. Disco fever. I'm sorry if you have epilepsy. Flashing lights. I'm sorry. Sorry, not sorry. Okay, so that's one of the objectives. We wanted to be able to dynamically control our directional lights. We haven't hard coded our light into our shader. um, um, I think the debug sphere here should probably be yeah. I'm considering actually kind of like creating a sphere around the light. I mean, moving this debug sphere thingy looks pretty cool. I like this tone, or what do we call it? Why do we actually? What's happening? Oh, do we still draw? Ah, yeah, okay, I have a bug. Create debug calls. This is hard coded to 1, which means that we will always draw a sphere no matter what. Okay, that's the problem. It's not really a bug. It's a forced implementation right now. Okay. So the renderer could do something like the translation could be something like instance float 3 pointer here, light position. We do something like okay. Yeah, so if we set our light to have a position that is somewhat opposite of the direction, position equals, and then x times maybe minus 5, dy times minus 5, and the C times -5. Well, that's definitely not correct. I made a mistake somewhere. X, Y, C, so it's not here. It's somewhere down here. What? Is it not a... Huh? I'm pretty sure. Y and C. But the Y and C... But I mean... this is the X. No, this is the C actually. Oh yeah, okay, it makes sense. It makes sense. It's because it's not offset. It's relative to the origin, and the origin is right here. So it's actually correct. Yeah, we could just for scene visuals add a yeah. Maybe we should add it to the relative to the camera. Just yeah. This is the position relative to the origin, and then we offset by the camera itself. Yeah, let's just do that. Oh well. Now we have to fetch the camera position. Camera position. Frame data. It will be for last frame, but it doesn't really matter. Now, okay, it's an XM vector. Huh. Yeah, let's add the... But this will only be when we update. Okay. This won't happen every frame. Huh. Yeah, so we will see the light popping around. Well, this is just for visual representation, because generally this is correct. A directional light. I mean, if we move it very far away, it would be probably more correct in terms of it being a sun of sorts. So where did it go? Yeah. So I mean, the shadow map is still incorrect, but yeah, it is more correct, but it still looks a bit odd. Well, I guess the... Okay, now I know what we're gonna do. Since the main light has a focus point, which could be the scene center, which it actually is right now. Let's see, we have an estimation of this scene center here. It's not 100% correct. I think we have 8. Yeah, maybe it's correct. Okay. And let's see. Yeah, we're doing position here. So we'll kind of like offset from the focal point. Yeah, this makes more sense, right? Yeah, it's -1. Yeah, okay. So our position is relative to the direction and the focus position. Yeah, it definitely makes more sense, right? Mm. Also, I think, wouldn't it be nice if the debugging primitive kind of like mirrored somewhat the, well, we could make the debug primitive have the same color as the actual light, but it wouldn't update regularly. Okay, we'll do it. Although it won't update all the time, we could. Yeah, it's a fun feature, right? Yeah. So if we change the color, it doesn't update, but if we click something, it updates. Yeah, if we select something, which would make sense because I guess if we kind of like click the light to edit it, it would get updated because it's selected, and yeah, that would make sense, I guess. Okay. Uh, okay. Okay, great stuff. So that's basically the next thing on the list. Yeah, and next, I think I'm gonna um, I'll implement some textures, and then I'll add the whole what do you call it? Um, I'll add the FBX support, I think. Maybe a skybox. I don't know. Yeah, it depends on whatever has the most interest. Yeah, so that's basically going to be it. Yeah, but I hope you found it entertaining, helpful, or just enjoyable. Feel free to support the channel, and remember to check out the community tab and cast a vote for future episodes. Hopefully, I'll be seeing you guys around, and please take care, everyone. All right.